Starting with question number 6. For non-negative integer n, let fn is equal to summation k is equal to 0 to n sine of k plus 1 divide n plus 2 into pi, sine of k plus 2 divide n plus 2 into pi, divide summation of k is equal to 0 to n sine square k plus 1 divide n plus 2 into pi, assuming cos inverse takes value in 0 to pi. Which of the following options are correct? Getting to the problem, at first, if n is equal to this one, half of summation k is equal to 0 to n cos of pi by, calculating this, n plus 2 minus cos of 2k plus 3 divide n plus 2 pi. Denominator, this one, summation k is equal to 0 to n and 2 operating 2 here, we get 2 sine square something into pi, that is equal to 1 minus 2 is here operating this, then 1 minus cos of 2k plus 2 divide n plus 2 into pi. That is equal to putting k is equal to 0 to n. Now n plus 1 into cos of pi by n plus 2 minus putting this k is equal to 0 to n, it becomes cos of 3 pi by n plus 2, 3 pi by n plus 2, and this n plus 2 plus cos of 5 pi by n plus 2 plus cos of 2 pi plus 3 divide n plus 2 into pi. Now k is equal to 0 to, after putting k is equal to 0 to n, denominator becomes n plus 1 minus cos of 2 pi divide n plus 2 plus cos of 4 pi divide n plus 2 plus plus cos of 2n plus 2 divide n plus 2 pi. Now next, n plus 1 into cos of pi by n plus 2, and this becomes minus sine of n plus 1 pi divide n plus 1 n plus 2 n plus 2 it divides sine of pi by n plus 2 into cos of 2n plus 3 divide n plus 2 into pi, n plus 3 into pi. This becomes n plus 1 minus sine of n plus 1 to pi divide n plus 2, only this, divide sine of pi by n plus 2 into cos of n plus 2 divide n plus 2 into pi. Now next, as cos inverse takes the value 0, takes the value in the interval 0 to pi. Now this and this one is we shall omit this and this one. Now now our final result becomes sine this and this is eliminating, and now numerator becomes n plus 1 cos of pi by n plus 2 plus cos of pi by n plus 2 divide n plus 2, that is equal to cos of this n plus 2 cos, after common cos pi by n plus 2, this becomes n plus 2, therefore n plus 2 is eliminating, and we get cos of pi by n plus 2. This one is our Fn. Now we go at the result, option A. Our now we should get our Fn is equal to this. Now option A is equal to limit tan is into cos inverse f of 6, alpha is equal to that, then alpha square is equal to 0. Therefore alpha is equal to tan of cos inverse f of 6. Therefore it becomes f of 6 and 6, it is tan of pi by 8, that is root 2 minus 1. Root 2 minus 1 implies alpha plus 1 is equal to root 2, implies alpha plus 1 a whole square is equal to 2, implies alpha square plus 2 alpha minus 1 is equal to 0. Therefore, we get our option A, and that is right. Now option B. Now go to option B. Option B, limit n tends to infinity, f of x is equal to half. As limit n tends to infinity, then our fn becomes cos of n tends to infinity, therefore fn is equal to cos of 0, and cos 0 is equal to 1, therefore it is given half, therefore B is wrong answer. Now B is not correct. Now option C. Option C is equal to f of 4 is equal to root 3 by 2. F of 4 means fn, therefore it becomes cos of pi by 6, and cos pi by 6 is equal to root 3 by 2. Now that is correct option. Option C is correct. Now getting to the option D. Option D is sine of 7 cos inverse f of 5, that is equal to sine of 7 after putting fn at n is equal to 5, we get cos inverse f of cos of 7 pi by 7, that is equal to sine of 7 into pi by 7, that is equal to sine of pi, that is equal to 0. Therefore option D, the sine that is equal to 0, this is right, and this is our correct option. That's all. I think it's very lengthy problem, and so lot of calculation. That's all.